Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. We are on lesson number 19 and we are building a very nice different kind of robot which can basically avoid an obstacle, and then we will be able to build an autonomous motion by adding jets and nano to it and a lidar to it and couple of other components. Anyways, in this lesson, so I'm going to show you the actual circuit, and we'll also do the programming part. We will use the MicroPython in the Thorny IDE, and I will show you what exactly to code, and we will test the circuit. So I have already built my circuit and it's pretty raw at this stage, but that is good enough for testing purpose. Let me show it to you. So if you can see, it's pretty much raw. I mean, I just, I didn't use the proper chassis to fix it, everything. But for you guys, what you need to do is you need to take out the double-sided tape from below the breadboard and stick it properly on top of this, all right? And then make sure that you stick the driver board as well. And the most important thing is you need to mount your Pico at the end, the last column, because there's a reason. I want the USB, the micro USB to be exposed outside, because once we build the top deck, the micro USB will be connected to your Jets and Nano at a later stage. So it has to be at the end. And do go ahead and follow the circuit. Let me just share you the circuit drawing. It's pretty straightforward. By this time, I hope you guys understand the logic of GPIO pins in Pico, and also the input output trigger pins and stuff like that. We have done a lot of exercise in the last 17-18 lessons, so you should be very much familiar with all the pins and the architecture diagram. Let me show the architecture diagram again, once again. I know this might be boring, but it's very important you understand this architecture. Do not go by the physical pin number. You need to associate each of the pins from the circuit to the GPIO pins, right? So if you look at the circuit drawing, this is exactly you need to follow. Connect all the four motors to your driver, and then the INA from the input devices, the input pins of the motor drivers, all the pins 1, 2, 3, 4, 5, 6. There are 6 different pins. You need to connect that to your Pico, two respective GPIO pins, all right? And same way for the ultrasonic sensor as well, and the servo motor, which is basically which will turn forward, left, front and right to detect the obstacles. So this is the actual circuit. Go ahead and build it, and my circuit is pretty much crude at this stage, but this is good enough for testing the program. At least I'm going to show you how to write the code and what code exactly it is. So probably this should run. Let's hope for the best. I did not connect the battery yet. I just left it open. It's connected to the USB power. That's why you can see the red LED glowing in the motor driver board. All right guys, so let's get going. Let's open up our Thorny IDE. All right, here you go. Now let's write couple of lines of code, not much. Of course, it's going to be bunch of lines of code. We need to understand the circuit and the logic properly. So I made a note of it already in a pen and a paper next to me. So make sure that you write down the logic, the pen in a pen and paper with all the pins you have connected. You built your circuit. Based on that, we need to be writing our code. All right. So first and foremost, obviously, we need to import our machine. So from machine, import pin comma PWM. So we are importing the pin and the PWM as well. PWM stands for pulse width modulation. And then we are importing time, and then import U time. All right, now let's define our variables. The variables are our sorry, the fixed objects are our motors. So the motor 1 equals to pin, which pin we have connected to. We have connected to pin number 10. pin dot out. We have done similar exercise in the previous lessons. I hope you understand this. When I showed you how to drive the motor, the DC motors, so it's the same logic applies here. And then the motor 2 equals to pin, which pin we have connected to pin number 11 comma pin dot out, like this. And then motor 3 equals to pin we have connected to pin number 12 and pin dot out. Alright, and then motor 4, oops, it should be lowercase. Motor 4 equals to pin, which pin it's connected to 13, pin number 13, pin dot out. Alright, now what we need to do, we need to define the enable pins and the PWM object, the object what we are creating, the enable pins from the motor driver. So that's what we need to do. So enable 1 equals to PWM from pin number 6, which is connected as per our circuit. Oops, it should be P uppercase, enable pin PWM pin, and then pin number 6 inside, within that one more bracket. Alright guys, I think this should be all in lowercase. Enable 1 and the PWM should be in a uppercase, PWM pin 6. After that we need to enable the 2, that is EN2 in your motor driver, PWM to pin number, which pin number it was 7, pin number 7. Alright, and then okay, now we need to define the trigger and echo from ultrasonic pins. So we will create another one, trigger, which is connected to pin 3. The trig pin is connected to pin 3. Did you see the circuit? Pin dot out, like that. Let me scroll it up. And then what we need to do, echo, we need to send the echo, lowercase, echo equals to pin number 2. We have defined it in pin number 2, correct, it was in pin number 2, and it will be pin dot in, we are taking the in. And then now we need to make sure that that is connected to our servo pin, servo PWM object. We need to create an object for the servo motor, because above the servo motor we have the ultrasonic, which will rotate left and right and front. So that's where the detection happens. Say servo pin equals to servo pin equals to pin number 15. Alright, servo pin number 15, and then pin number 15 and the servo equals to PWM servo pin, servo P uppercase pin. Always the pin P should be in uppercase, guys, try to understand this. And now we need to call the duty cycle, the duty underscore cycle equals to 0. This is where we are basically defining and initializing the duty cycle for the PWM, right? And now we need to define the frequency for servo motor and enable pins. So servo dot frequency of 50, we'll keep it as 50. We can modify this anytime we want if the speed is too high, and we can change the frequency. And then enable 1 dot frequency of 1000 enable to frequency of 1000. Let me scroll it down further. And then after this, what we need to do, we'll be setting the maximum duty cycle for the maximum speed, and then enable 1 dot duty underscore unsigned integer of 16. And what is the unsigned integer of 16? It is 65025. And then enable 2 dot duty underscore unsigned integer of 16 65025. All right, now let us move forward. Let's forward the motors, all the 4 motors. We need to move forward when there is a space. So let's define move underscore forward. So this is, we are kind of creating a class here. And once we do that with a semicolon, motor 1 dot low, okay, and then motor 2 dot high, HAGH high, and then motor 3 dot high, okay, motor 3 dot high, and then motor 4 dot low. All right, now we need to set the direction to move. Now we already set the direction to move forward. Let's define the same thing for backward. Let's say define move underscore backward, okay, close the function with a parenthesis and a colon, and then motor 1 dot high. Let me scroll it up. Motor 1 dot high, and then motor 2 dot low 2 dot low, and motor 3 dot low again, and then the motor 4 dot high. Do you remember we connected in parallel? So that's the circuit. And then now let us define let's define turn right. We did forward, we did backward, now let us turn right. Define turn underscore right, like this, okay. And now once we define, it's the same logic we need to apply. Motor 1 dot low, motor 1 dot low, and then motor 2 dot, I think, high, yeah, motor 2 dot high, and then motor 3 dot low, and then motor 4 dot high. All right, now let's define left. We finished forward, backward, and right. Now let's define left. Define turn underscore left, okay. And then motor is the same logic we are going to apply again. Motor dot high, motor 2 dot low, motor 3 dot high, and then motor 4 dot low. Okay, now let us define a stop function. say define stop, or else it will keep running. Oops. Okay, semicolon, colon, sorry. Now let's take a look. We have defined turn left, turn right. Now we need to define stop. Yes. Motor 1 dot low, motor 2 dot low, motor 3 dot low, and motor 4 dot low. Actually we can copy paste the previous logic, but sometimes if things goes wrong, it's kind of messy. Now we need to define the function to get a distance from ultrasonic sensor. So how do we do that? Let's do define get underscore distance like this. Okay, this is the function we are creating. You can call it as a method, and then trigger dot low, and then u time dot sleep underscore us 2, and then trigger dot high. Let me scroll it up. Okay, if the trigger dot high u time dot sleep underscore us in pin number, sorry, not a pin number, it's a 5, and then trigger dot low, trigger dot low. Now what we can do is we can get into the while loop. While echo dot value, while echo dot value equal to 0, then what we need to do, signal off equals to u time dot ticks underscore us. All right, and then let's create another while loop. While echo dot value from your ultrasonic sensor, echo dot value will become on, that is 1, that is as soon as it detects an object within that 20 centimeter range, signal signal, signal on equals to u time dot ticks underscore us, like this. And then what we need to do, we need to come out of the while loop and say time passed equals to signal on minus signal off. So this is the time travel it takes between the object, the signal it goes and hits on the object and coming back. So we need to divide that and minus it, and then signal off, and then distance equal to time passed multiplied by 0.0343 divided by 2. That's the basic calculation which I showed you in previous lesson, in our ultrasonic sensor lesson. Just go back and you can see that formula. Okay, and now return the distance. Now let us define the function to set the servo angle, right? Whether it's a 180 degree, 90 degree, or it's on 60 degree or a 180 degree. It cannot be 360, of course. It's just a 180 degree servo. Let's define, let me go back and see where is our define. Okay, it's in the same. Define set servo angle colon and then the duty underscore cycle equals to the value of int value of angle multiplied by 7803 minus 1950 divided by 180 degree, and that you get plus 1950. I hope it works. Let's see. It should work. And then servo dot duty underscore unsigned integer of 16, say duty underscore cycle, like this. Now let us set the servo to say 90, set servo to 90 degree, and then while true, what should happen if the servo is in 90 degree? So ideally the distance equals to get my underscore distance. Okay, this is basically getting the distance in centimeter. And then now what we need to do, in while true, we can probably define the direction based on the condition. We can set some condition, as we can use the if condition. If distance is less than say 15, stop. We can give a stop, and then move underscore forward. Remember the object we created, or maybe no, sorry, it's going to hit the wall, so we can backward, move backward. All right, then time dot sleep we can set it as 1, that is on, and then stop, we'll give a stop, and then time dot sleep to 0.5, a small fraction of second, and then set servo to 30. So basically this is the angle. So once we set the servo to 30 degree, then what should happen? Set servo to 30 degree, then we will basically set the sleep, time dot sleep. Okay, time dot sleep to 1. I hope you guys are following this, guys, but anyways, I'll be taking one-on-one for you guys to explain each and every line of code. Do not worry. All right, then right underscore distance equals to get underscore distance, like this. All right, I hope this should work. Now we will say time dot, we will come out of this and say time dot sleep for a period of 0.5. All right, now what we need to do, we will just double check once again. We will just go through the code, guys. It's kind of almost 100 lines of code, so probably there are high chances that there might be a mistake, though the logic is very, very simple, right? It's a very simple logic. It's if you follow the entire logic of the movement of go forward, go left, go right, and in the if condition, if the object is within this angle and the distance, do like this. That is what we are doing. So let's take a look. Let's go ahead. Let me just review the code once again, and then we will run it pretty quick. And if this goes right, then probably it may not be quick, but see, I mean, the most of the time what happens is, guys, either a spelling mistake or a syntax mistake. So you might have missed some syntaxes. Logic, it may work, it may not work, but most important thing is the spell checks and the syntaxes. That's what matters in MicroPython. Let's go ahead and run this. Move backward, move, turn right. Where is left? Okay, left is here. Turn left and then stop, and then we are getting the distance. And in the distance we are okay, we are setting a while doing this. Okay, all right, then return the distance, and then we are defining the servo for the angle and certain conditions within the loop. Let's see. All right guys, so let's cross our finger. I'm not connecting my battery, I just want to do the test here first. Okay, run the script. That's pretty surprising. There is no error or anything wrong with Thani. But nothing is happening. Oh, okay. I need to save it as a main. Guys, most important thing, we need to save this file as main. Okay. I'm just saving it, save as, and I can see a pop-up window. In the pop-up window, it will ask whether this computer or Raspberry Pi Pico. You need to select Raspberry Pico and then save. All right, now what we will do, let me just connect the battery and see. I can see a little bit of movement on the ultrasonic sensor. Let me just check. All right, let me connect the battery and see if it works. All right, so guys, as I said, this is a pretty crude structure. This may run haphazard, so that's why I'm going to hold it in my hand and I'm going to connect the battery. All right, looks like perfect. I think it is working. Let me just remove the USB. Okay, I removed the USB. Now let me connect. Even the servo motors are loose. I just gave a temporary structure here. Can you see it? It shouldn't be like this, guys. So, when we are building a bot, it should be really, really sturdy. But this is just for testing. That's why purposefully I left it loose as it is, just to test the code and see how it works. Let me move the motor like this towards forward direction. And now let me connect. Okay, I'm going to hold it in my hand. Oops. Okay, looks like okay, it's detecting. All right, good. There you go. The ultrasonic sensor seems to be working, and it's sending the if. It's going into the if condition, and yeah, the motor seems to be working perfect, guys. Okay, I think this is pretty cool. Okay, I don't see any issue except one side of the motor. Okay, so I found out what exactly is the issue. So basically, instead of, I gave the connection like this, as I said, right? So it is ideally supposed to be like this, both of this motor and this motor. What I did was I gave like this. So that's the reason the only two motors are working and two other motors are not working. That's fine. This is for basically I want to test my code if it works according to the circuit and the pin diagram. All right, guys. So basically, the most important aspect is you need to understand how to look at the circuit, use the correct pin, and make sure that refer to the architecture again, and make sure that based on this architecture with the GPIO pin associated with the physical pin, and then go on to the circuit diagram. If you look at the circuit and directly connect to the pin numbers, sometimes or many times you might end up doing a lot of mistakes. So I suggest look at the architecture, connect to the correct associated pin, and the GPIO pin associated with the physical pin. That is very important. And then of course the coding part, the MicroPython coding is pretty easy. If you understand the logic, it's very, very easy. It's very easy to understand. Go ahead and build it, guys. I am going to leave this code and the circuit drawing in my GitHub. If you have any issues, do feel free to reach me out, message me, call me, I will come online into the Zoom call. I will explain you each and everything line by line, and I can help you build. So looking forward for the next session. We will be building more advanced stuff with the same structure. We will be using, we'll be adding a couple of more sensors, and most likely, I'll be removing this breadboard, and we will use a proper PCB and a mounting points, and so that we don't have a what do you call, very loose structure like the one what you saw right now. All right, guys, I'll come back to you soon. Do stay tuned. Bye bye.